As I said, my name is Avi. I'm technical marketing manager for EMEA in Mellanox. Basically focused on internet switching, but today I'm going to speak a bit more on the end-to-end solution. We're going to start with talking about the challenges for the new data centers. I'm going to focus on high bandwidth demands, and then I'm going to present some Mellanox products and solutions that face those challenges and solve issues that are created by those challenges. So a bit about Mellanox before we start. Mellanox is quite a solid company. It's a public company, traded on NASDAQ, Mellanox, you can search it. And we are reaching close to $1 billion revenue. Hopefully we'll be able to do it as soon as possible. Our recent acquisition is EasyChip, which adds some power to our portfolio. We have 2.5 thousand employees worldwide, headquarters in Israel and in Sullivan, California. Mellanox started as an InfiniBand silicon company, so are very, very familiar with the demands of low latency, high performance computing. I think 6 years or 7 years we are in the Ethernet market, so we are becoming an important part of the Internet market, a significant one, and we are continuing to improve. A bit about the agenda. So basically what I told you is that we are going to do some introduction, talks about the drivers of high bandwidth in the new data centers, challenges, and then we'll walk through our products of Mellanox. Mellanox it's kind of a unique company because we can talk from the bottom, from the silicon to the software layer. We talk about this end-to-end concept that Mellanox brings, and also solutions like CloudX that we'll talk a bit more. Hopefully we have enough time to reach NVMe over Fabric, which is a very interesting story. Hopefully we can do that. If not, we can take it one-on-one if you would like. We'll take a discussion about it afterwards. Okay, so what's happening in the data center? Why we need more and more bandwidth? So I think the most important part in our age is basically that we are moved from bare metal to virtualization. And virtualization brings with them a lot of demand of bandwidth because if you can see, every VM that you are running on your server is demanding up to 0.5 gigabit of bandwidth. So with 10 gigabit NIC, you can reach something like 20 VMs on a server. Now with 40, you can reach even 60 VMs on a server. I'm talking only about the server. So if you're looking at the rack level, it means a lot of bandwidth, and you need to go uplinks, right? So VMs is basically one of the major drivers for higher bandwidth in the data center. And we can see by the reports worldwide that the bandwidth demand is all over the world. It depends exactly where you're looking at. Some people are starting at 1 gig, some more advanced as 10 gig, but everywhere there is a demand for bandwidth. And I think the most important driver for bandwidth is the data. So every one of us, mostly on our mobile, are keeping photos and uploading to Facebook and Instagram and Twitter. It's a lot of data, and it's only our personal data. Think about the enterprise industry and so on. So we see increasing amount of data all over the world. For data, you must have very strong storage components, right? So what happens with storage around the world? To reach at saturate 100 gig, you needed 250 spinning disk. It's a lot, right? Moving forward to flash memory, to SSDs, you needed 24 SATA SSD to reach 100 gig, 10 SAS to reach 100 gig, and with NVMe, guys, we need only 4 NVMe to reach 100 gig. So we need a lot of data. We need to store it somehow. Storage becomes much faster, and suddenly network is becoming the bottleneck. Another factor that changed the world is, of course, the clouds. So we have private, hybrid, public clouds. Every cloud eventually means that you are moving from a topology of scale up to a topology of scale out and software defined. what does it mean actually to move scale out? Scale out means that you have more east-west traffic, right? Everything is distributed right now. Storage is not only in one place, it's all over. Application also is all over, right? So you need to run traffic between all those nodes. If you are thinking about a spine leaf layer, it means that you need much, much more bandwidth here, even if you're using 10 gig. Because you have a lot of 10 gigs, maybe 40 gigs. So this is the old one. It is called, some people call it Wall Street IT. It's the old approach. It's declining all the time. The traditional top of rack with some core switch, you pay a lot for it at the beginning. You're not using some of it. This is the modern topology, which is a scale-out topology. Some call it web scale IT, which tells you basically, guys, you can buy as much as you want now, and you can get larger later, right? You can add spines, you can add leaves. And if you are talking about 10 gigabit for application compute and 40 gigabit for storage, why not doing 25 for application and 50? And the price, so this is something we can discuss later, but eventually I think all the reports shows that from the price perspective, you are basically achieving more if you are going with this speed. So we are seeing 25 as the new 10, but even if you are using 10 gig, it still doesn't matter. You have a lot of 10 gigs, you have a lot of storage. You need uplinks between the leaves and spines that can make you run traffic east-west. So what Mellanox has to offer? Not many companies can say that they have end-to-end solution in both dimensions. So when people think about end-to-end, it's the horizontal end-to-end, right? There is the NICs, cable switch, cables, NICs, end-to-end. But actually, Mellanox is doing end-to-end also vertically. Mellanox is doing their silicon inside the system. Okay? We're doing the systems themselves. We're doing the software, all the system. We're doing the software that is NMS software and orchestration software that manage all our systems. So we're really doing end-to-end in both dimensions, and it means a lot because doing end-to-end means that Mellanox depends only on itself, right? So if you have, let's say, other competitors, I will not mention names, but they are using, let's say, Broadcom silicons. So they need to approach Broadcoms, and they have the PHYs, and they have the systems, and they have the ODMs, and the cables, interoperability issues, maybe locking things to make sure that there will be no interoperability issues. With Mellanox, we are so flexible in our system because we can control it all over the way, and even on the field, it's flexible enough for us to make changes and to improve. So as I said, Mellanox is doing silicon and systems and software. Our two main products are the switches. The Spectrum line of products is the basically 1 to 100 gig. It's 10, 25, 40, 50, 100 gig. And our ConnectX 4 and ConnectX 4X are doing the same thing on the NIC side. A bit about the architecture of switch. So this is the architecture of the Spectrum switch. It composed of 128 SerDeSes of 25 gig. It means we can compose several options. One of them is using 4 SerDeSes for 100 gig, so we are getting 32 ports of 100 gig. You can see the box later on there. We actually can do the same thing, use the SerDeSes, but as 10 gig, so we are getting a 40 gig switch. We can split the ports and get 50 gig with 2 SerDeSes. So totally, you can have 32 ports of 100 gig, 64 ports of 25 or 50 gig, and also 64 ports of 10 gig. You have all the combinations that you need. And this is basically the Spectrum switch. And the Spectrum switch, and I will show you later a slide about it, is really high throughput component, 0 packet loss for real, and very low power in the market. And we have a great story about openness in Mellanox that will reach soon. Taking the topology of the silicon and moving to the actual connections. So the terms in the industry for 40, 10, and 100. When talking about 100, we are talking about QSFP28 with our product, basically 4 lanes of 25. And when talking about 40 gig, we are talking about QSFP, which is 4 lanes of 10. So if you have all the equipment that is running 10 gig, for example, or 40 gig, it's great. You can use the same cables because they are using the same technology, 4 lanes, and connect it to 100 gig. If you are buying new equipment and want to connect 100 to 100, then you will need to use the QSFP28. Okay, so physically, the architecture is the same. We'll touch it a bit more later. It's 4 lanes, and you can use it as 25 or as 100. A bit about the system. So those are 2 of our systems. We're looking, upper one is the 2700, 32 ports of 100 gig ports. It can be also 40 gig, as I said. You can split the ports. So even the top one, which is usually the spine, can act as a top of rack. This is actually the most common top of rack in the industry, but now it's 25 SFP28 and 8 ports of QSFP28. So it's kind of usual top of rack because what's happening is that you are connecting up to 48 servers, right, downlinks, and you have 8 uplinks for the spines with 100 gig. And the system is quite strong. We are doing it ourselves. You can see that the system is the same. The backwards is the same. What is changing is the front of the system. And we can change it to this model or to this model. It's running by CPU, Intel Ivy Bridge, which is quite strong CPU for a network device. 16 gigabit DRAM, and we have flash memory, 32 gigabits for persistent data. We have more components which are field upgrade possibility. One of them is CPLD, and it's very low power. The lowest power on the market. You can check it. A very unique product of us is the 2100. It will be available in Q3 this year. And just look at it. I'm not sure if anyone can say if he saw such a switch in the industry. I can assure you it didn't, because there is no one. It's basically 16 ports of 100 gig in a half view. Now, what does it mean? It means basically, usually when you are doing top of rack, you are putting 2 switches for high availability. For layer 2, you are doing something that is called MLAG, making 2 switches looking logically 1 to the servers, or layer 3, but it will be 2. So we are using 2 spaces in the rack, 2 1Us to do this HA. With this product, you're using only 1U. 2 switches in 1U. Then you can take, let's say, 10 ports and split them. Let's say to 10, 4 by 10. So we have 40 ports of 10 gig going to the servers on this rack. And you are left with 6 ports for 100 gig that go uplinks. It means that you are more than non-oversubscription. You have 600 gig going up, only 400 gig going down. You can do the math. You can take another port and add more servers. So this is basically giving you all that you need from top of rack, but only in half 1U. And the price, I can tell you, it's lower than the bigger one. So it's a great product. And when we talked about end-to-end in Mellanox, so we can only do that from 2 reasons: business and technology. We can do it technology because we are doing everything. So we are building the silicons. We know exactly how to do that. We are building the systems. And the only one can do that also from the business perspective because, all the cost is on us. So we can manage it business-wise and make it cost-effective also for Mellanox. The power is very low, of course, and we're using, again, CPU Intel, which is quite strong for this kind of products, 8 gigabit, 16 gigabit flash, and CPD field upgrade. Only question that I'm getting sometimes about this product is, yeah, but with the big top of rack, I'm using cables, one-to-one cables. Here, I need to use splitter cables. So, guys, this is even better, because with a single cable, you are covering 4 ports in $166. This is street price, okay? With 4 cables, you are doing $216. We'll touch about cables later on. It means you are saving also on cables with this top of rack. So, it's quite a unique product, and unfortunately, I don't have this product here, but we have his ancestor, the 1012. It's the 1040 gig. It looks the same. More ports than this one. Okay. Another aspect which is important about the 2100 is the buffer. So buffers are important in our to solve some of our challenges when it comes to incast. Buffers needs to kick in. Sometimes you need the buffers to help you to achieve the bandwidth that you need. And this is our competitor when it comes to silicon. It's called Tomahawk for Broadcom. And you can see from this table that when you are looking at the 2100, even compared to our 2700 that we showed earlier, we're looking at 1 kilobyte buffer per port, while in our competitor it's 256 kilobyte. So this is not a deep buffer switch, I will tell you that. But definitely it's best in class when it comes to buffering. And we'll touch more about buffering and why the numbers here is 256 and not, let's say, equal to his, let's say, similar one in Mellanox. We'll touch on in a minute. Total report, it's a nice report. It's the second time that we are doing that. It's a third-party company. And as I said, we did it, we compared basically ourselves to the Trident and now to the Tomahawk, Broadcom Silicon. And this is the second time, and we suspected we'll see the same issues again. So we did see them. The latency in the competitor is not equal for all packet sizes. There are dropping packets, guys, for some packet sizes. You can see it here for Broadcom. 64 ports is dropping packets. 164 is dropping packets. Okay, this is the third-party company. They did that. Running plain RFCs, 2544 for unicast and also the multicast RFCs. Nothing special. So it didn't surprise us. We know that. But what did surprise us is the fairness. And this is an important, I think, important subject. What we did is a simple test. We took 3 ports in our competitor and 3 ports with the Spectrum. So if we choose 25, 26, 27, everything is cool. We are creating some congestion, buffers kicks in, everybody is getting his own share, 33% of the buffer. But if we replace and change the ports and choose another ports, 24, 25, 26, look what happened. With us, we are staying at 33% for each port. But with the competitor, oh, there are 2 victims here. They only have 25% of the buffers. Why is that happening? It's because when people are talking about shared buffer, and all vendors are talking about shared buffer, you expect to have one shared buffer. So Mellanox, for example, has 16 megabyte share buffer. And you expect that it will be split into the 32 ports equally. But actually on the competitor it's not like that. They have 4 shared buffers. So there are a group of ports and each one has its own shared buffer. So these 2 victims, they're using the same shared buffer. And this one, he's using its own. So he's the happy one. And the comment that I'm getting about this discussion sometimes is, guys, okay, this is a low-level discussion about silicon and buffering. So first of all, I must say, Joe, we probably forgot the basic thing that you want from a switch is to be fair. Every VM that is connected to port 1 to port 32 should get the same service. And then you're putting your application, QoS, all the service level stuff, whatever. Okay, that's cool, but start from baseline. Everything is equal. And this is actually an application issue. This one, can you open? This is a simple test, not marketing video, an engineer video. What he did is very simple. He's using SMB Direct to avoid CPU, removing CPU to be a factor. Basically, is taking the same file 5, and passing it to 3 different locations on the switch, 3 different ports, 3 different VMs that are running. Very simple. You see CPU is not a factor. And look what's happening. Those are the 2 victims. They are running slower. And this guy, this is the happy one. So we didn't know that he's a happy one. He paid the same as the other 2, but they are getting a better service. Okay? If you can fast forward to 129, something like that. No, this is a simple SMB Direct for Microsoft. Basically what he's doing is running storage and removing CPU using RDMA. I will touch RDMA later on. You're just moving storage between nodes from memory to memory without CPU involvement. Yeah, we have several applications that we are using, and there are standard applications that you can find on the system. Yeah. And eventually this one ends, and So those are starting to kick up a bit more faster. But what I want to say about the video is that this is not a low-level discussion. This is not a low-level story. This is a switch. This is a Cisco switch. 100 gig Cisco switch running on Broadcom Tomahawk. Okay. Okay. Till now we talked about silicon and systems. Now let's talk about software a bit. So Mellanox offers two options currently. Actually, we offer more, but let's say the main two are Mellanox OS, which is the Mellanox operating system. It's like a traditional industry CLI OS, EOS, iOS, Nexus, whatever. You have a CLI, SNMP, GUI. It's the CLI that you are familiar with. So there are some customers saying, look, I'm used to Cisco. This is what I know. I don't want to try anything else. This is a resilient product. 5 years, Mellanox is running with this product, doing layer 2, layer 3, almost all the features that you need for the data center. And the more unique one is actually Cumulus. So recently we started to have Spectrum switches running with Cumulus Linux. So I have my colleague Stefan here. We will talk a bit more about Cumulus, but just 2 words about it. Think about it. On the server world, it sounds crazy today to buy from a vendor the entire server rack, and this vendor will tell you, okay, this is what you have. I want to install an application that I have now. No, you cannot. You need to pay. This is crazy, right? Today you are buying commodity hardware. You are putting the Linux that you want and the application that you want. You can choose whatever you want. You can replace the OS. You can replace the applications. This is the same thing that is going to happen on the network world. You can choose the hardware that you want. You can choose the Linux OS that you want. You can choose the application that you want. Cumulus Linux and Spectrum actually realize that. They're doing exactly that. And Cumulus Linux is basically the final step that we made to be what we call an open Ethernet company. And to say that you are an open Ethernet company is one thing, but to show facts that you really are, it's different. So look, for example, of MLAG. MLAG is a proprietary protocol. Everybody is doing that. Cisco is doing VPC, MLAG for other companies. We actually took MLAG and put it on the GitHub. This is our API for MLAG. We pushed for SAI with our friends on the Web 2. We said, guys, if a Web 2 company or SMB company would like to develop their own switch over our silicon switch, then what they need to do is basically connect to our API, which is called SDK. Broadcom has the same one. It's called SDK, but it's not actually the same SDK. The competitors have their own SDK, and Mellanox have their own SDK. So if one wants to run his application or develop his application on our SDK and want to change the hardware, he needs to write everything again on the other SDK. So what we did, we said, okay, no, let's work on something that's called SAI, which is abstraction interface for SDK. So today, Broadcom must have jumped to the wagon, so they did that. And today, basically, with SAI, Microsoft was developed Sonic OS system, which is running on Mellanox Spectrum and Tomahawk Broadcom. And it's the same application, and they can choose if they can just swap between our two silicons. All our systems are running over ONI. ONI is like a pixie boot of a network. Okay? What does it mean? It means basically that you can have Mellanox OS, Cumulus OS running over Spectrum or a system, and you can decide that one day, okay, I want to change the Mellanox OS, or vice versa. It's like you have images on the network, and you're just swapping the images. And Cumulus Linux, as I mentioned, basically open source Linux on a network. It's a great idea. You can basically run whatever application that you want and do orchestration very easily and so on. Our latest development is something that is called SwitchDev. I will not touch it very much, but I would say that maybe this is the historic path to what should happen in network. Basically, we are creating the drivers for native Linux for switches. So today, if you are putting a NIC, you are having your Red Hat or Ubuntu, and you are installing the driver, you see ifconfig, interfaces of the NIC. Why not in switch? So today, we have SwitchDev that is running. Basically, you are installing the driver or your Linux on our platforms, and you are getting 32 ports when you're doing ifconfig or IP-link. And you can do whatever you want in layer 2. In July, we can run Quagga on SwitchDev on a switch. This is about the switches. Let's talk a bit about cabling. So Mellanox at the beginning didn't sell cables, and we made a strategic decision to do that also. So we are selling a lot of cables today. I will not mention the exact number, but 20% of the DC budget is spent on interconnect, especially when you are talking about high bandwidth. You want to make sure that your cables are doing their job. Less errors, less symbol errors, as much as less bare, to make sure that when you're running 100 gig are running over the interconnect. We call this line of product LinkX. And basically it's closing the solution when we're talking about NICs, switches, and cables eventually. Money. Okay. A bit more about cables. So we mentioned that SFP28, this is the connector. It looks exactly the same form factor as SFP28, SFP plus, sorry, same form factor as SFP28. This is running 10 gig, this is running 25 or 10 gig. Same for the 4 lanes of 10 gig, QSFP plus, same form factor as QSFP28. It means that you basically, if you have legacy products, 1040, you can connect it to 100 gig and then deploy whatever more as much as you want. Everything is backward compatible. There are many industry standards for creating 100 gig. At the beginning, some vendors started and say, okay, I have a 10 gig, so if I want 100 gig, what I need to do? Multiply by 10, right? So there is the CFP, which is COWI 10. Basically, it's 10 lanes of 10 gig. And then vendors moved to the formula of COWI 4. So there is the CFP 4, which is the 4 lanes, as I explained. It's the same technology, different electric-ish stuff, but basically QSFP 28 is using COWI 4, as we said, and we are supporting QSFP 24, 4 lanes of 25 to reach 100 gig. And we have available now, we have several cables and modules, so we have 15 100 gig SR4 modules, splitter cables for 25, 50, 100. Again, they can do also 10 and 40. And AOCs for 50, 100, which complete our portfolio for cables for 100 gig, 1 to 100 gig products. So till now we talked about the product, and we'd like to speak a bit about a solution. It is called CloudX. Now Mellanox is not, it's not a cloud company. It's a hardware company. We sell NICs, we sell switches, we sell interconnect, cutting edge technology. When talking about CloudX, and I'm trying to define it, so basically CloudX means that we are creating a recipe or a reference architecture for the best cloud as we see it. So we have our partners, if it's Mirantis or Canonical and others, and we have much experience in building clouds. So basically we created some kind of checklist saying what you need to do to have the best cloud. And since we are selling hardware, it will focus on our technology on the hardware, and we'll touch about that. So talking about cloud, you cannot think about something more significant than overlay, right? So overlay network is all over. And when talking about overlay, it means that you have challenges of management of this kind of architecture, and you have challenges when it comes to CPU utilization that is costing much on each server. And to do that, basically you need 2 things. First of all, on the switch side, on the networking side, you need to do the best, right? So you need to run 100 gig, 25, 10, 40, whatever you want. You want the best latency, you want no packet drop. This is what you want to have, and this is what you are getting from our systems. The power for overlay is actually on the NIC side. So what we are doing on the NIC sides, we are doing advanced features which all they are aimed to do is doing overload to the CPU. It means that, for example, for VXLAN today, if you want to manage VXLAN with NSX or OpenStack or whatever, you need some kind of a controller that is running. It's consuming a lot of CPU to do basically a work that is actually related to network. It's not really related to application. Application is doing the important stuff. You need to leave the CPU to do what CPU needs to be doing. What we are doing, we are using features like RDMA, VXLAN offloads, NVGA offloads, other offloads. Basically, we're taking part of the things that the CPU is doing, we are moving it to our silicon here, to our NIC. RDMA, for example, is a powerful stuff. It's basically what it's doing is going from the memory of one server, taking the data, bypassing the TCP stack towards the hardware network and moving it to another place and back to the memory. So we can move, and this was the example on the video, we can move files, for example, without even touching the CPU. CPU now is doing other things. VXLAN offloads, VXLAN, as I said, there are a lot of things the VXLAN architecture needs from the server, checksums, in-cap, decap, things that we are doing on the connectics. So this is mainly the main solution for cloud, as I see it, that come from Mellanox is the advantages of the NIC when it comes to offloads. And to complete the solution, there is Neo. So we talked about offloads, and we talked about the challenges of managing a cloud. So Neo, for example, is actually it's a free product. You will get it if you are buying CloudX or switches for free. You can test it for free. It's basically orchestration monitoring tool that is part of what it's doing is orchestrating a cloud. So for example, we have integration with VMware and OpenStack. With OpenStack, for example, we have a plugin in Neutron. So what it means is that if you are creating a VM by OpenStack, Neutron can notify Neo that a VM was created. Neo automatically will create the VLAN for this VM. If you are migrating a VM, it will move the VLAN to other place. If you still have servers with the same VLAN, it will keep the VLAN. So there is a logic that Neo is activating according to Neutron notification. And Neo can manage big clouds, big installations, but it's also good for 2 switches. For example, we have a cool feature on the Neo for just 2 switches running storage as top of rack. So some, network guys, for them to configure MLAG, which is the HA protocol usually for top of rack, it's easy. For application guys and storage guys, it's a bit more complicated. With Neo, with 1 click, we call this feature 1 click. Actually, it's 2 clicks. But with 2 clicks, you basically can configure a VLAN without even networking. And immediately, you have your configuration ready to run. So Neo is good for small installation as big ones. As I said, it's a free one, so you're welcome to try it. Have enough time? Cool. So we have time to talk about NVMe over fabrics. My colleague talked about NVMe a bit, and I mentioned VME as the fastest storage today on the industry. Thank you. So what are the challenges and what is the transition in the storage market? First of all, there are 3 actually major ones. The first one is moving from spinning disk to solid state drivers. So storage is becoming much faster. Second one, and we talked about it, we are moving from storage arrays to scale out. Storage is everywhere. Hyperconverged is now very hype, Everybody is doing hyperconverged storage and compute on the same servers. The third one is hyperconverged, as I mentioned. And for that, we are covering with our solutions the needs for faster storage when it comes, as we talk, with switches, NICs, and cables. And NVMe basically is, it's kind of taking all of these and making it faster. Right? So NVMe is a solution which is local on the server side. You are bypassing some of the legacy connectors that you used to have for spinning disk, which are not really relevant for flash memory. So now NVMe makes storage much, much faster. And guess what? Historically, since we are moving from storage in one place to storage in many places, it means that basically, historically, next step is moving from NVMe to NVMe over Fabric. It It means that you have not a local storage, but shared storage with NVMe. So lucky for Mellanox, we have the only feature today that actually can make it. Since NVMe is bypassing APIs and connectors and drivers to make it faster, to do the same thing over Fabric, we need some kind of a protocol that is called RoCE, or RDMA over Converged Ethernet, which is basically doing that. As I explained, RDMA, what it's doing is bypassing the TCP stack, the kernel, and going directly from the application to the network. As we see in this picture, you see that this is application 1. It has some kind of a buffer. There is one option. One option is to go through the kernel, NICs, and then to the other side. But this will not work on NVMe because you are basically doing the opposite of what NVMe wants you to do, right? You are going to the same process that makes storage slower. With RDMA, what you are doing is going directly from the application to the NIC to the application. And this basically completes the NVMe solution and makes it available over Fabric. So now we can talk about NVMe over Fabric, and there are some POCs. It's very new. It's cutting-edge technology, but we have some POCs running right now. Companies like Manxtor, other companies that they have the appliances and components of NVMe, and with RDMA, with Mellanox, which the only company that is doing it with hardware. RDMA offloads on the hardware. There are some that are doing software, but we are only one that are doing it on hardware, creating basically this fast storage over Fabric. So now you can share this NVMe over Fabric. And you can see those models when you basically are saving CPU because you don't need to go to the path that involves the kernel. So less CPU, more efficiency, less idle states of the CPU, and this is basically what RDMA is doing. RDMA is available, by the way, before we touch this one reference. RDMA is available today for every application. Microsoft, for example, is using it in the SMB Direct, and from Windows 2016, it will be natively as part of the Microsoft Azure Pack. So every time you are doing Microsoft Azure Pack, you are getting basically RDMA inside, if you want it or not. Right? This is a strategic decision by Microsoft to do that, to ensure, as I said, storage running over Fabric in a fast way. And this will be my last slide, before maybe if you have many questions. There are many references. We have a large baseline of customers all over the world, but this one is a unique one that I wanted to mention. It's connected by our previous generation of switches. Square Kilometer Array is a project of governments. They are funding it all over the world, Australia, South Africa, and more. Basically what it's doing is that it's putting huge antennas that looks at the sky and hearing and recording the slimmest and smallest signals from the universe. Maybe, to find out if you have some friends out there. It's a huge antenna. Our team was there for the installation. If you are putting a truck, it will be something like that. A truck near this thing. And there is a kilometer of array of those things looking up to the clear skies. And the interconnect is Mellanox. So basically, there is a switch here in the desert. There are cables running in the desert to the data center. Data center is receiving those signals and using multicast and unicast in the fastest ways possible. Today 40, next will be 100. It's basically processing this data and trying to understand if we can get something from this data. So this is the topology in high level. Around 100 switches are connected actually it's not servers, it needs to be fast. It's FPGA running with an atomic clock, one of the biggest one and costly one, that is running and activating a multicast in, I think, the most non-comfortable way a network component can have. And it's quite a challenge. It was quite a challenge for Mellanox. Eventually we won this and we are running this. It's running right now in South Africa. It's called Meerkat. And who knows, maybe it will bring us some news about people outside. Guys, I think that this is it from my side. If you have any questions, comments. Great.